Hey Maths fanatics, welcome to Maths Fanatics 24/7, where maths is always fun. Are you ready to make numbers your best friends? Let's get started. In this video, we're going to be looking at the theorem of Pythagoras. Right? This is the basic theorem of Pythagoras about any right-angled triangle. Okay. So firstly, the lesson targets are you should be able to define the theorem of Pythagoras, and you should also be able to determine the unknown sides of the triangles if you are given two lengths. And then you also need to solve problems that involve right angles, triangles. All right. So one may ask, what is a right angle triangle? A right angle triangle is a type of triangle that has one angle equals to 90 degrees, right? Just like here, you can see that we have on the corner there, we have 90 degrees. So we can conclude that this triangle is therefore the right angle triangle. And there's a special side on the right angle triangle called the hypotenuse. The hypotenuse is the side opposite the right angle. So you always draw an arrow from the right angle. It will always point your hypotenuse, which is the longest side on the what? On the triangle. And the other two shorter side, we call them legs. Leg 1 and leg 2. Perfect. The side opposite the right angle triangle is called the hypotenuse. And the other two sides, which form the right angle, are called the legs of the triangle. Right. Perfect. So now let's go to the next page. So this is the definition, right? In any right angle triangle, the Pythagorean theorem applies. So Pythagorean theorem only applies on right angle triangles, stating that the square of the length of the hypotenuse is equals to the sum of the squares of the lengths of the other two sides. This relationship is fundamental in solving problems involving right-angled triangle. So Pythagoras says this, guys, right? He says if we have a right-angled triangle here, c squared, which is this length squared, so c squared will be the same as b squared plus a squared, right? Awesome. Now let's proceed. The Pythagorean theorem is a fundamental principle in geometry that relates to the sides of right-angled triangles. It states that in a right-angled triangle, the square of the length of the hypotenuse, remember the hypotenuse is the longest side, right? In this case, we would have C here, right? This can be A, this can be B. A and B doesn't really matter, but this will be C because the square of C is the same as the sum of the squares of the other two sides. Perfect. And it can be written as this formula here. Right. Awesome. Learners, you may wonder who discovered this theorem. So I included a short summary of the history of theorem of Pythagoras. Pythagoras was an ancient Greek philosopher and mathematician born around 570 BCE on the islands of Samos in the eastern Aegean Sea. Pythagoras founded a religious and philosophical school in Croton, now Crotone, in southern Italy, known as Pythagorean School. Pythagoras and his followers made significant contribution to mathematics, including discoveries of geometry, arithmetic, and number theory. Right. Perfect. So without wasting time, let's get to examples. Right. So ladies and gentlemen, here we are given that A is 5. So we are given that this side is 5. We are given that B is 12. So we are given that this side is 12. And then this one is not given. But you know that, okay, the side that is not given is the hypotenuse. So you know that, okay, the square of A plus the square of B is the same as the square on the hypotenuse when we add them together, those two. But we are told that A is 5, so we can include 5 squared. We are told that B is 12, so here we're going to have 12 squared equals to C squared. And then 5 squared becomes 25. b squared becomes 144, right, which is equals to c squared. And then when you add 25 and 144, you get 169. So we can say 169 equals to c squared. Some people prefer to bring the unknown letter on the left. So we can say c squared equals to 169. And then when we square root 169, remember we need to square root both sides to remove the square there. So square root of 169 give us 13. So it means the length of the hypotenuse in this right angle triangle is 13. Right. So let's go to the next question. On the next question, we are given A, we are not given B, so we are not given one of the legs, but we are also given the hypotenuse. So you firstly always start by writing the formula of the theorem of Pythagoras, which says the hypotenuse squared is the same of the sum of the squares of the other two sides. I have A, which is 9, so I have 9 squared. B squared will just remain like that. The C is 15, so we replace the C with 15. 9 squared becomes 81. 15 squared becomes 225. Alright? And then since I'm solving for B, I'm going to leave B by itself here. The 81 is going to move that side. Because it's moving to the other side, it becomes minus 81. So now you have B squared, which is here, equals to 125 minus this, because it has to move to the other side. And then now this will go there, right? B squared equals to 144, because the difference between 125 and 81 is 44. And then we need to square root both sides so that B is by itself. Square root of 144 is 12. All right, perfect. Now I need you to pause the video and try example 3. All right, let's go on. So on example 3, you can see that, okay, you are given B, you are given the hypotenuse. You don't have one of the legs, so this side here is unknown. All right, awesome. So now let's see. A squared will remain A squared. B squared will become 6 squared because B is 6. C squared becomes 10 squared because C is 10. A squared remains the same. 6 squared becomes 36. 10 squared becomes 100. Because we are solving for A, we need A to remain by itself this side, so the 36 must go to the other side. So you are going to have 100 minus 36 because it's going to the other side. And now we have A squared equals to 64 because 100 minus 36 is 64. And then remember we're solving for A, not A squared. So we need to square root both sides. So when you square root both sides, we get that A is 8. Right. Awesome. So let's move on, ladies and gentlemen. So now let's do the converse. The converse of the Pythagorean theorem says this, right? It says if the square of the length of the longest side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right angle, right? Let's say, guys, they didn't show us that this is 90 degrees here. Let's say they just gave us a triangle. And they're asking us, is this triangle right angled or not? You always use Pythagoras converse theorem to prove that. So let's try some examples. So we know that by the definition of the theorem of Pythagoras, the two shorter sides squared will be the same as the square of the longer side. So we substitute A, we can call this A, we can call this B. This one will always be C. A and B, the order doesn't matter. You can call this A, you can call that B, it's fine. But C will be C. The hypotenuse remains the hypotenuse. Sharp. And then B is 36. We can see that the hypotenuse is 39. 15 squared becomes 225. 36 squared becomes 1296. 39 squared becomes 1521. and we get the same answer when we add this on both sides. So we can conclude that it's a what? It's a right-angled triangle. Right. If the answers were not the same, our conclusion we're going to say it's not a right-angled triangle. Right? And that's it about this lesson, ladies and gentlemen. Thank you for watching Maths Fanatics 24/7. If you had fun, give us a thumbs up and share the math love. Aluta continua. Keep the math spirit alive. See you next time. Tango.